Chapter 9, Photovoltaic Systems. In this chapter, we have 6 sessions. Section 1, Introduction to Major Photovoltaic System Types. Section 2, Current Voltage Curves for Loads. Section 3, Grid-Connected Systems. Section 4, Grid-Connected PV System Economics. Section 5, Standalone PV Systems. And Section 6, PV Power Water Pumping. Section 9.1, Introduction to the Major Photovoltaic System Types. There are 3 most commonly encountered configurations. The first one is the PV voltaic systems that feed power directly into the utility grid. The type 2 is a standalone PV systems that charge batteries, perhaps with a generator as a backup. Type 3 is applications in which the load is directly connected to the PVs, as it is the case for most water pumping systems. In the entire chapter 9, we will focus on these 3 commonly configurations. Configuration type 1, Building Integrated Photovoltaic System, abbreviation as BIPV. Figure 9.1 shows a simplified grid-connected PV systems. A simplified grid-connected PV system is a grid-connected or utility interactive system in which PVs are supplying power to a building. The PV array may be pole-mounted or attached externally to the roof. It may become an integral part of the skin of the building itself. PV roofing shingles and thin film PVs applied to glazing serve dual-purpose power, building structure, and when that is the case, the system is referred as a building integrated photovoltaics. The photovoltaics is a grid-connected system delivers DC power to a power conditioning unit that converts DC to AC and sends power to the building. If the PVs supplies less than the intermediate demand of the building, the PCU draws supplemental power from the utility grid, so demand is always satisfied. If the PV supply more power than the demand is needed, the excess is sent back onto the grid, potentially spinning the electric meter backwards. The system is relatively simple, since a failure-prone battery are not needed for backup power, although sometimes they may be included if utility outages are problematic. The power conditioning unit also helps keep the PV operating as the most efficient point on their IV curves as condition changes. So the desirable attribute of a grid-connected PV systems include their relative simplicity can result in high reliability. Their maximum power tracking unit assures high PV efficiency. Their potential to be integrated into the structure of the building means that there are no additional costs for land, and in some cases, materials displaced by PVs in such systems may offset some of their costs. Their ability to deliver power during the middle of the day when utility rates are highest, increase the economical value of their kilowatt hours. All of these attributes contribute to the cost effectiveness of these systems. On the other hand, they have to compete with the relatively low price of utility power. Configuration Type 2 Standalone PV Systems. An off-grid standalone system with battery storage and a generator for backup power. In this particular system, an inverter converts the battery DC voltage into AC for conventional household electricity. But in very simple systems, everything may be run on DC and no inverter may be necessary. The attributes for this standalone system include standalone PV system can be very cost-effective in remote locations, where the only alternative may be noise, high-maintenance generator burning relatively expensive fuel, or extending the existing utility grid to the side, which can cost thousands of dollars per mile. These systems suffer from several inefficiencies, including battery losses, and the fact that the PV usually operate well off their most efficient operating point. Inefficiencies are often increased by mounting the array at an overly steep tilt angle to supply relatively uniform amount of energy through the seasons, rather than picking an angle that results in the maximum possible annual energy delivery. This system also requires much more attention and care than standalone systems. And if generator usage is to be minimized, these using the energy may need to modify their lifestyle to accommodate uneven availability of power as the season change or the weather deteriorates. Configuration Type 3 PC system directly coupled with load. The third system type has photovoltaics directly coupled to their loads, without any battery or major power conditioning equipment. The most common example is a PV water pumping in which the wire from the array are connected directly to the motor running at a pump. When the sun shines, water is pumped. There is no electric energy storage, but the potential energy may be stored in a tank of water up the hill for use whenever it is needed. Our goal in this chapter is to learn how to properly size photovoltaic system to provide for these various types of loads. Power delivered by a photovoltaic system will be a function of not only ambient conditions, especially solar intensity, spectral variations associated with overcast conditions, ambient temperature, and wind speed, but also what type of load the photovoltaics are supplying. Different analysis procedure applies to grid-connected systems, battery charging, standalone systems, and directly coupled water pumping systems. That completes section 9.1.